Hello friends, welcome again. In this session, we will try to solve three lead code problems related to SQL, and these are very frequently asked in interviews. Now the problems that we are going to pick is rank scores, problem number 178, problem number 180 which is consecutive numbers, and problem number 181 which is employees earning more than their managers. Right? So let's start seeing this in action. If you have not seen my previous videos where I have talked about combined two tables, second highest salary and nth highest salary, please have a look at those. Okay, so let us start with rank scores, and you can see it is of medium category. That means it's not very easy. It's the difficulty level is medium. So let's try to solve this. So let us see what exactly is the question. So we have a scores table and ID is the primary key. Each row of this table contains the score of a game, and score is a floating value. Floating means decimal number. That's fine. Write an SQL query to get the rank or to rank the scores. The ranking should be calculated according to the following rules. Let's see what are the rules. The scores should be ranked from highest to lowest. That means we have to order by descending. Fine. If there is a tie between two scores, both should have the same ranking. You remember this is the feature of dense rank. That means when there is a tie, assign the same rank. After a tie, the next ranking should be next consecutive integer value. That means there should not be any holes. So this is a perfect fit for dense rank. If you know what is a dense rank, right? In my previous videos, I have covered rank, dense rank. You can check that out. And let's try to achieve this. You can see the input is this, and the output is basically we are sorting it based on scores. For example, 4.0, the rank is 1. Another 4.0, the rank is 1. 3.85, the rank is 2. That means it's not assigning this the rank of 3, right? So this is a perfect fit for dense rank because dense rank has this property. Let us try to solve this now. How do we do that? We will say select the output, we want score and rank, right? So select score comma rank from scores scores. The table name is scores, right? Scores is the table name. We want score and rank. This is what we want. But remember this rank, whatever we are having the name here. This is a function also in SQL. That's why we have to put it in this kind of quotes so that it does not treat it like a function. It knows that this is a name that which we are giving. Okay. So score is fine. Rank is something which we have to derive. How do we calculate this rank? So basically, we would have something here, and the name, the alias for that would be rank. Okay. So let me try writing the dense rank function now. So now I have to write dense rank, dense rank, sorry, yeah, dense rank. And we always use over clause. Now we have to say order by what? Order by score, right? Score is the field on which we are ordering by, order by score, right? In which order? Ascending or descending? Descending. DESC. As simple as that. So select score, comma dense rank over order by score. That means it will order it 4.0, 4.0, and then give it the relevant ranks. And we are giving it alias name as rank. Why we are putting it to this double quotes? Because rank itself is a function and it will not take it. For example, let me remove this and let me try running this. Let me show you what will happen. It won't accept this. Let's see. You can see this. So rank from scores. It's not feeling that it's the right syntax. So rank is not a function that we are using. Rank is a name that we are giving here. That's why I have put it in double quotes. If you have not checked my tutorial on rank, then I would on dense rank, I would put it in the comment section so that you can have a look. But in this video, I will not explain what is a dense rank and what is a rank. I'll put the necessary links of my videos which I have already done on rank and dense rank in the description section so that you can have a look at it. Let me submit this now, and you can see this is running fine. So this is how we can use this. I'll put it in a notepad, and this is related to query. What's the description of this? Rank scores 178 rank scores, and this is the solution, right? So that's how it would be. Now let's see the problem 180. Let me just go back. Another back. Okay. Let me try problem 180 now. Consecutive numbers. I'll write it. 180 consecutive numbers. Let's see what exactly is a problem. Again, it's a medium. Difficulty level is medium for this. And we have a logs table which has a ID column and a number column. Write an SQL query to find all numbers that appear at least 3 times consecutively. Right? We have to give that number which is repeating 3 times consecutively. Return the result table in any order. That means ordering is not mandatory. Now, for example, how do we know it's consecutive? For example, ID is 1, number is 1. ID is 2, number is 1. ID is 3, number is 1. That means for 3 consecutive IDs, the number is repeating. And that's why 1 should be displayed in the output. Now, is there any number which is repeating 3 consecutive times? No. 2 is repeating for 4, 6, and 7. Are 4, 6, and 7 consecutive numbers? No. Right? So that's why the answer is 1. And whatever we are having, this number, we are giving a alias name consecutive numbers. So explanation they have given is 1 is the only number that appears consecutively for at least 3 times. Right? So let us try writing the code for this or the query for this. I have written it earlier. I will try writing it again for you. So what we can say is select. Uh, what I have to do now is I basically know that we have to join logs table with logs table. That means it's like a self join that I have to do. Right? I'll take these two things here. Right? So this is how it is. So in logs table we have ID and number. Let me take this entire thing. It will be very helpful. Okay. So now in this, what we have to do is we have to do a self join. Then only you will get to know, right, whether a number is repeating or not, because there is no other table. Same table has to be joined with itself. That's how you will get to know, because this one we need to compare with this two, this one we need to again compare with this three. When is that possible? Right, when we do a self join. So this is a very good candidate for a self join. Let's try doing that in action. What we will do is we will say select and I will leave things here. What I need to do is I need to mention from which table. From which table I have to do? From logs. Let's say I am giving the alias name for this as L1, right? Join logs L2. I'm joining logs table with another logs table, same inner join, this self join, right? What is the condition on which I want to join? I want to say L1 dot ID equal to L2 dot ID plus 1. That means this one should be joined with this 2, right? L1 dot ID will be 1 initially, and L2 dot ID plus 1 will be 2. So basically, what I am trying to say, we want to join these two rows, and what we want to see, we have to say and we want to make sure L1 dot number equal to L2 dot number, because if these numbers are same in both these rows, then we want to consider. So basically we are considering these two rows now. Similarly, we have to do it for the third row because three consecutive numbers. So this is where we join another table, join logs L3 on L1.id equal to L3.id plus 2. That means we are joining this row with this row, right? And L1 dot number equal to L3 dot number. Basically, we are saying if we are joining this first row and third row, then this one should match with this one. So if both these conditions are satisfied, then we return. Now we have to write here what exactly we are looking at. We are looking at ID, right? Select, select, sorry, not ID, we are looking at the number, right? So select number from logs L1, join logs L2 on this, join logs L3 on this, right? Now we have to give a alias name. What was that alias name? Let's pick this. Select number as consecutive numbers. Now there is a problem that this number, how does system know that from which table we want to get this? Is it L1? Because logs has three instances now, L1, L2 and L3. From which one we want? If we run this directly like this, it will say, okay, this number is ambiguous. Let me try running that and show you. Let me try running that and show you. Because this number belongs to all three tables. Column number in field list is ambiguous. And that is where we should say L1 dot this thing. From any table we can pick. That's fine. Right? Let me just take this now and run this. Okay. This is accepted does not mean it will work always with many test cases. Let me submit this just to see what happens. It says wrong answer. What has happened is when the input was, you can see when this was the input 1 comma 3 2 3 3 3 and 4 3, the output expected was the output which I got was 3 comma 3, but it should be only single 3. That means it's giving the answer multiple times, which definitely it will. So we have to use the distinct keyword here. Distinct, right? We have to give the distinct keyword, because what would have happened here, 3333 is 4 times, then of course we will get one answer from all these three and another answer from all these three, right? So 2 times this 3 and 3 we are getting, but we should get only single time. That's why we should be using the distinct keyword. So I have used distinct Let me try running this now. Let's see whether it works or not. I feel this should work, but let's see. Yeah, you can see the answer is accepted. Okay, so this is your question 180 consecutive numbers. So you're displaying all the numbers which are repeating for 3 consecutive times. And in this, we have learned what is a self join. So we have seen problem 188, sorry, 178 and 180. Now let us go to another problem. Let's see that in action. Okay, database. And in this, we will see employees earning more than their managers. Quite interesting, right? But this happens. So I have a query written. Let me remove that. And let us see what exactly the question says. First, I'll copy this question. And this is what we are looking at. Employees earning more than their managers. This is what we want to find. So we have an employee table with these columns: ID, name, salary, and manager ID. Okay. ID is the primary key column for this table. Each row of this table indicate the ID of an employee. So this is basically an employee ID, the name, salary, and the ID of the manager ID. So this is how this looks like. So the employee ID is 1, the name of the employee is Joe, the salary of this employee or the salary of Joe is 70,000 and manager ID is 3. Another employee, employee 2, name is Henry, salary is 80,000, manager ID is 4, and like that. Now, basically, you can see that this 3 and 4 themselves are employees, right? Where we have this IDs. So, this is again a problem where we have to do a self join, right? Then only we will be able to compare the salary of, let's say, Joe and Sam. Basically, Joe is an employee reporting to Sam. Sam is the manager. Joe has salary of 70,000, Sam has 60,000. That means Joe, who is an employee, the employee salary is 70,000, manager salary is 60,000. So, of course, Joe should be there in the answer. On the other hand, when we talk about Henry, Henry is manager whose ID is 4. So, that means Max is the manager of Henry, and Henry has a salary of 80,000, Max has salary of 90,000. That means the manager is having a more salary, right? So definitely Henry should not be the answer. So let's see how exactly we need to accomplish this. In this, Joe is the only employee who earns more than his manager. So let's try seeing this, that how exactly we need to solve this. So what we can do here is, let me just copy this. It will be helpful for me. And let's try seeing the solution. So what we can do is, we want employee, right? This kind of structure. And this basically, Joe is a name column, right? So we have to say select name as employee. You can see this. We are displaying the names and the alias for this is employee. So select name as employee from employee E1, join. We have to join this table with itself. Join employee E2, E2. What is the on clause? On what condition? On E1 dot manager ID, manager ID equal to E2 dot ID, E2 dot ID. That means we are seeing this manager ID should match with this ID. Just have a look at this, right? And, or I will write, and what we want is, so for example, this will become like one Joe 70,000, right? And then Sam 60,000 null. This is how it is. So what we are looking at is, and even dot salary, that means employee salary is greater than manager salary, E2 dot salary. Because left hand side you have the employees details, right hand side after the join we get the manager details, right? So that's why we are saying E1 dot salary greater than E2 dot salary. Just have a look. Okay. Now let me try running this. If I run this again, we will face a problem, right? Select name. From which table are we selecting? It becomes ambiguous because we have two similar tables now. So I can say E1 dot, right? Select E1 dot name as employee. From employee E1, join employee E2 on E1 dot manager ID equal to E2 dot ID and E1 dot salary greater than E2 dot salary. Very straightforward, just like the previous problem we solved. If you have understood what is a self join there, you should be able to understand this very, very easily. I'll run the code and you can see it accepted, and this is working fine. So this is how you can achieve this, right? So we have basically done self join in order to achieve this. Self join should be pretty clear now because in the problem 180 consecutive numbers and even in 181 we have done that. When do we have to do? When we have to compare one row with the next row or some other row in the same table. Then we take two instances of that table and join two instances based on certain condition. So with this, we have seen three problems which are very, very useful, very, very important. You should be knowing this, right? And I hope you would have got a good idea about it. SQL is super important when you go for any kind of interviews in IT. For example, even if it is a web developer interview or a data engineer interview, data scientist interview, machine learning expert interview, anything, knowing SQL is super important, right? And I feel best way to solve is this lead code problems because a lot of good companies are directly taking the questions from there and giving it to you to solve, right? So this is the best platform to learn, right? And best platform to practice. I would say that. So with this, we are kind of done. And please like the video if you really appreciate the content. Do subscribe to the channel. It motivates me to see the numbers growing. And I'll keep on coming with more interesting videos. And definitely there is a lot to do in this lead code problems. We will come up with more set of problems in the upcoming sessions. Thanks a lot.